Hey everyone, and welcome back to another episode. Today we're diving into HTTP, the Hypertext Transfer Protocol. Think of it as the language that the web browsers and servers use to talk to each other. We'll explore how HTTP powers everything you do online, from loading your favorite websites to submitting forms. We'll also look at common HTTP issues, how they're resolved, and even dive into some of the more technical aspects like HTTP methods and status codes. So buckle up because we're about to unpack HTTP. And stay tuned when I come back. We will be talking more about HTTP. Hello and welcome back. All right, let's get into HTTP. Before I do that, I'm going to be actually using some slides that I created just to kind of guide our conversation around this topic. As I previously mentioned, HTTP, as it stands for Hypertext Transfer Protocol, is everything that pretty much powers and enables our web activity in terms of how we go from typing a web URL into a browser, and that goes into the web server, loads your favorite page, whether be it Google, be it your favorite social media app like Facebook, and so forth. So I'm just going to pull up some slides just to kind of guide our talking points, and then we will take it from there. So hang on 1 second while I load up my slide, and we'll just kind of talk about this. As you know, on this channel, we kind of cover things from the most basic concepts to the most advanced concepts. Now, that said, we will try to kind of navigate between, just enough information for those of us who are beginners and trying to get into this to understand. And hopefully for those of us who are already familiar with the topic and advance in this conversation, will follow and get something as well from that. So hang on while I load up my slides, and then we will take it from there. Okay, so let's go ahead. Let me switch to that screen, and then we'll take it from there. So let's do that. Awesome. Now we're looking at a slide. So I'm going to pull this here so I can see it a lot better. And then I'm just going to start this one. Perfect. Okay. So we are talking about HTTP, and, I have this as the subheader as how the web works, only because, HTTP, as I mentioned, forms like a pretty significant part or the backbone of how the web does work. So hence my subtitle over there. But we'll talk about these as we go on. We'll kind of understand what HTTP is. We'll talk about it. We'll talk about it at a high level. Trying to understand what this works, how it enables us to browse the internet, how it enables us to do anything in particular that uses web traffic, and we'll kind of explore some of the concepts as we go on. So let's get into it. Now, that said, we cannot talk about HTTP without understanding URLs. For the most part, HTTP is pretty much made up of URLs in terms of how we navigate to where we want to. So for example, if you wanted to get to Google, you would have to put in a URL in your browser, and that URL essentially means something and translates to something that your web browser understands. And then it could pretty much take that request. And now we get into kind of the backbones of HTTP, which we'll get into further. But for now, let's talk about URLs. We can't talk about HTTP without understanding URL. What is a URL? You've probably seen this for most part. You go to your favorite site, whether it's Facebook or Instagram or whatever, assuming you're sort of going on the web version or on your computer or any of those avenues. If it's not a web app, for most applications such as Android apps or iOS, you may not see or deal with a lot of these things because they're sort of embedded within the app. They're happening in the back end. They're still using a bunch of URLs and calling servers in the back end and APIs and all those things. You just don't see them. But we're going to kind of attack this from a traditional perspective where we're looking at, just typically going into your web browser and typing a URL. Now, let's kind of unwrap what these URLs typically look like. That said, most URLs, as you'll see, would include something like a HTTP //www.example.com, blah, 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 search, and so forth. Now, all of these have some meaning behind them in terms of like they form what we collectively call part of like the URL itself. And the URL can be broken down into several pieces. The first thing we see here, as you see, we see HTTP. HTTP is basically saying this is the scheme. So the scheme can be anything. In this instance, because we're talking HTTP, you can clearly see that it says HTTP here. Now, there are other protocols that you could be calling. For example, there are FTP or there are SSH and so forth. And over here, those schemes would have been either if it's FTP, which is File Transfer Protocol, or Secure Shell, which is another way of connecting to remote machines and so forth. That would have been different. But in this case, it's HTTP. So when you see a URL like this, what you pretty much need to understand is that this is the scheme. It means what exactly or type of activity or action I'm trying to perform. Now, like I said, if it was a file transfer, it would be something like FTP and so forth. Then we get to what we call and I'm going to tackle this first before we get down to these things in the bottom. Then we get to what we call the fully qualified domain. So the fully qualified domain name, and you see it most of the time, would be in something like www.example.com, as we see in this instance. And over here, I'll talk about the port in a second. One thing you can't talk about is the fact that this URL or fully qualified domain name is divided into subcomponents. So the www in this instance is what we call a subdomain. It could either be school.example.com. It could be dashboard.example.com. It could be anything. So the other part of it, which is the top level host, is essentially almost always the last parts of that domain name. So in this case, example.com is pretty much the top level domain. And then we can see that there's a number associated after the colon. This part of the URL, in this case, is typically referring to a port. So in this case, we're saying port 80. This is where we're directing traffic to. A lot of applications run on different ports within the servers. So this is telling it this particular either web server or web address or web application, whatever is running on port 80, which is pretty much what it is. Now, we'll look at the next one in the next slide, which is more of a secure version. You'll see that the port number changes to something else, and we'll talk about that. Now, there's something else also called the path. And the path typically is pointing to something that, in this case, for example, it says search. So search is our path. And then obviously you can see the last parts of this, which is Q equals cybersecurity and page equals 2. These elements are typically called the query string, and the query strings are directing you exactly to something. It's basically saying, okay, I want to search. What am I searching? My query is cybersecurity. And, this could refer to how many pages you've gotten from that search results. And in this particular example of this URL, it's pointing to page 2. So that's the basics of a URL, as you would see in most examples typically. And I will talk about sort of like a more advanced one. Let's see this one. In this example, all the elements that we kind of talked about remain the same. There are a couple of things that are different. So for example, in this URL, we can still see the fully qualified domain name. We can see the protocol or scheme. We can see the port is port 80. We can see the path, which is the login.php file. And then we can see like the query string, which is basically saying redirect me to dashboard and ID equals blah, blah, blah. Typically, this could refer to like the user's ID and so forth and all that. This could refer to the user's ID and so forth. And then I will talk about the fragment in a second. Now, if you look at this URL, there's just one thing or a couple of things that look different, as we mentioned. So if you look at this, you can see there's also a user element to this, right? The user element is basically saying, hey, I'm this user admin. My password is let me in. And you can see down here, we have a username and a password. Mind you, you will likely not ever find URLs in this format. Again, this is obviously for learning purposes. Like I just wanted to kind of call it out, but we used to actually do URLs in this manner. And for security folks, you can guess where the issue is right away, right? There's the admin and the password being sent in plain text and so forth. So very bad idea. Now we talked about the fully qualified domain name. In this case, it's the same port, same kind of different path, redirect is part of the query string dashboard. One thing I do want to cover here is the fragment. The fragment typically just means take me to a specific part of the page. So in this case, we're saying profile. It could be user information. It could be settings. It could be anything. So this is just saying take me to a specific element or part of the web page that you just loaded. Now, I pretty much kind of covered what a lot of these mean, but I'm just going to walk through them like one at a time, just so for some further clarification. So as we talked about, schemes typically refer to either HTTP and in some cases HTTPS. We'll talk about that in a second. The scheme pretty much identifies a protocol. It always ends with a colon, //, and it tells your browser how to communicate with what server. And then we have user info. In this case, we talked about is bad idea, almost never used. You'll never find these in the URL these days. And we talk about the host. The host is pretty much, taking you to the fully qualified domain name. In this example, we're saying legacy.example.com. The host identifies the target server. It can be a domain or subdomain, etc. Port is basically which part of the application, which port is it running on the web server. So a web server, ideally nowadays, we kind of have dedicated web servers for different applications, but a lot of times we still run different apps and different services on one server. So this is just saying for this particular application, we're running on port 80 in this case. And most of the time, if this is not there, it defaults to port 80, or if there's a redirect set up for HTTPS, which is a more secure version of HTTP, it just redirects you to 443 and so forth. Now the path, we kind of talked about it. The path just points to a specific file or route on the server. If not specified, a lot of times it will just default to index. The query string pretty much tells you this is where I want to go. It begins with a question mark. It's used to pass data to the server. Multiple key values are separated by ampersand. My apologies, ampersand. And in this case, it just tells the server where to redirect to. So in this example, as you can see, it says redirect to dashboard and ID equals 42. So the ID would probably be the user ID and so forth. And then the fragment, which I talked about, just refers you to a specific part of the page, like an anchor or a section and so forth. Cool. Perfect. How does HTTP work in terms of like flow of traffic, right? I always actually ask this question. It's one of my favorite questions to ask in an interview. And people would say, come on, that's sort of basic question to ask people. But I'm like, hey, I want to know. As a security folks, we could literally unpack this question and go levels and levels of depth and width and breadth and all of that stuff. So I enjoy actually asking this question because it opens like the can of worms, and then we just can kind of get in deeper and so forth. Now that said, let me just kind of cover it high level. As I said, we can dig down deeper into it as much as we want, but I'm going to cover it high level. And pretty much what happens when you type a web address in your browser? Well, imagine that you're the user. You typically would say, hey, I want to go to www.example.com. You type that in your browser. The first thing that happens is something you should know, which is most web browsers understand these human readable forms like www.example.com. But in reality, it needs to actually map that address to something which is more an IP address on some server. And what happens here is that this uses, what we call a DNS server. So once you type in your web address, you go into your browser, it actually sends a thing to your DNS server and says, hey, I'm looking for example.com. What is the actual address? So think of it as like the actual mapping of, URLs, human readable versions to numbers that nobody probably will remember, if anything. So hence why, this is that. So this is just more of a user-friendly way. And then what it does, it calls your DNS server and it says, hey, give me the IP address for example.com. The DNS server returns that IP address. And then what it does is it then in turn send what we call an HTTP request to that web server address, which is the IP address that the DNS server sent to you, and then it is, if that page exists or if that site exists, it responds typically with with a simple, hey, this is okay, this is what you requested, blah blah blah. Let's ideally say like an index page, which will just say, for example, hello, welcome to example.com. Now, a couple of things I do want to unpack here. As I mentioned, we can go deeper and deeper in this. With DNS, there's a lot of elements that we can kind of even go here as far as this request is concerned. Typically, when you type in that for DNS, it starts by looking on your browser cache, which is essentially your browser has kind of stored up a lot of these URL addresses and they know where the numbers translate to and so forth. If it doesn't find it in there, it would typically go back to your local computer, which is like your host file. If it's a Linux computer or Windows computer, it will look for those addresses in your host file and so forth. If it doesn't find them, then it will kind of now go out into DNS server in the wild. Typically, if you're within a big enterprise, you might be running your own DNS servers already. It will do that. There's a lot of things that happens here. Ideally, what I'm saying is this looks for this address in many, many places to be able to find it. And if it doesn't find it, then, you'll get like a, error when it returns like, hey, server not found or something like that. And then this is just so high level. This is pretty much kind of how this works in terms of like at a high level, you type in web browser address and this is what happens in the back end. So let me move on to that. The problem with HTTP. At this point, we've been talking about HTTP. It sounds like it's great and works fine. It's simple. You type in your browser, type in the web address in your browser. That request gets sent, blah, 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 gets processed and so forth. One of the things a few things with HTTP is that it's pretty much all data is transferred in cleartext. That means this is not secure. In many ways, it's vulnerable to man-in-the-middle attack, which essentially means if I was running some tool and capturing your traffic and listening to your traffic, I could ideally just see everything that you're sending in terms of requests and responses and so forth. Therefore, things like sensitive data like usernames and password can be easily gotten. API tokens, access tokens, all of those kinds of things will be easily accessible to somebody that's sitting in the middle. So hence HTTP itself by default isn't as secure as it should be. And therefore, this is how we get to the solution being HTTPS. HTTPS is essentially uses TLS encryption to secure the communication. That means previously when we were worried about a man in the middle, somebody sitting in the middle of our traffic and listening to it, that becomes almost practically impossible nowadays and so forth. So if you were to go into like Wireshark, like using tools like Wireshark, which is like a network sniffer and so forth, you would find, pretty much encrypted data and they wouldn't make sense to you. What does HTTPS also do? It solves the problem of tampering and eavesdropping and potentially stealing credentials, such as like the access tokens and all the other things that I mentioned. A lot of times you can tell that a site is running HTTPS or it's running secure site by looking at the key up here. For example, in Chrome, you can see that it says connection is secure and so forth. And that ideally means, they're running like a secure connection and so forth. Now, it does not mean that this site is actually the best and greatest site. And does that mean this web application you're running is the best and greatest? It's just saying your traffic is protected by TLS. That's about it. It doesn't absolve this website or web application from OWASP top 10 problems such as XSS, cross-site request forgery, all of those things. It doesn't absolve that application. This is not saying, yep, I guarantee that this web application is great. It just means they're running TLS. So note that. Since I talked about TLS, one thing I do want to cover is kind of like the basic flow of the TLS and the TLS handshake. So I talked about going to, say, example.com through your browser, right? Ideally, if we're running a secure HTTPS, which is we're running HTTP over TLS, what happens is you ideally your web browser, let's kind of take that DNS part and all those things up, and that happens. Now we actually know the IP address of the web server we're trying to get to. So once you do that, the browser sends initial request to say example.com. And we'll talk about this. I haven't mentioned kind of this, which is the HTTP method, versions and so forth, but we'll talk about that in a second. And it sends a request to pretty much like example.com's web server. Now that web server pretty much sends like a redirect and says, hey, this has been moved permanently to say blah 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 HTTPS version of this site. So connect to that site instead. So your browser then sends what we call a client hello, and the client hello is essentially saying, hey, I'm trying to access your resources, and I hear you're secure. What do you think? Tell me what it is. And the server responds with something called a server hello. And in that response, what it does is essentially says, hey, I run HTTPS. I'm a secure server. I can secure your traffic. Can we exchange some keys? And in this key exchange, what we call the server key exchange, it pretty much tells your browser, these are the keys I support. These are the ones you can choose from, versions, blah, 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 encryption algorithms I support, all of those things. It basically presents you with a list of things. Do you like cookies or do you like brownies? Which one would you want to pick to secure this transaction we're doing? And then the client pretty much, picks one based on what the client also is able to support as far as the browser versions and all those is concerned. And it sends that back to the server, and the server says, okay, now I can encrypt Handshake and say, since you've kind of given me what you want us to use in terms of what version of the keys and algorithms and so forth, I'm going to send you back, this session key, which is essentially, so all this time we're talking about pretty much like a public key encryption. But once the client and the server agrees on which algorithm and so forth, and it exchanges the keys, it's actually a session key, which is essentially a symmetric key that says, now let's use this for every communication that we do. And pretty much at that point, back and forth communication between the server and your browser happens this naturally over HTTPS. There we go. All right. HTTPS, as we continue to talk about this. So for HTTP, HTTP pretty much follows what we call a client-server model. As in, there's always some server and there's always a client. The client makes a request to the server responds. It's like, hey, mommy, I want to eat this food. It's like, okay, food prepared. There's your food. Kind of like that. So there's always like somebody presenting something, which is the client, and the browser and the server accepting and processing that and sending back a response. Clients are typically browsers. It can be a browser. It can be curl. Curl is a Linux application or command line application, which pretty much works like your browser, except you don't get all the pretty fancy Rolls-Royce type of facelift that the browsers give you. And essentially, you're able to make requests and get responses back with that. Requests are typically sent over to a server to either access something, modify something, update something. There are all kinds of actions that you can do with that. Let's talk about the structure of an HTTP request itself. Typically, the URL, we've talked about all these, the URL, the path, the method, which is something I want to talk about in a second. The URL identifies the location of the resource. We kind of covered that in the beginning. Path basically says, I want to get to this specific area. And then method typically is a list of actions that you want to perform on this server. We'll cover methods in a second as well too. Headers typically are like metadata. They can either be host, user agent, authorization, headers that indicate what kind of authorization you want to use and so forth, or even contain keys and tokens and so forth. And the body is pretty much like what you get when you want to send like a request to the server to perform an action. Say if it's an update to something, it's typically in a post request or using a post a post request or indicating like a put method and so forth. Let's talk about this on the right. So this is an example of a typical HTTP request. So there's HTTP, there's a request. You see that we have what we call get. There are several methods like which indicate what action the request itself is trying to do. So in a get, it's just simply saying, give me this resource. And in this example, you can say it's saying users login, blah, blah, blah. HTTP 1.1 is pretty much the HTTP version. Nowadays, there's HTTP 2. We have been advocating to move to HTTP 2. There's very little adoption in terms of industry and industry-wide, but this is a topic that, is kind of gaining traction, especially recently. So host, in this case, host is basically saying this is the URL fully qualified domain I want to go to. A user agent typically indicates what kind of browser or client that is coming from. So in this case, you can see is Mozilla 5.0, which is basically a Firefox browser. A cookie will typically represent, something that ensures that you have the same connection and session when interacting with the server. Just to talk a little bit about cookies, they're basically small files that are placed on your computer, within your browser's cache and so forth. So the server that you're talking to knows that this is, say, user X, the same user X that's trying to talk to me. And I already know that they have a certain connection and there's a state of that connection and so forth. So I want to keep it that way. These got introduced because HTTP was kind of like you send a request, you send a response, that's it. It's done with what it needs to do. But we obviously needed a way to say, you know what, if I'm logged into my account, I don't want to keep logging in and out every time just to do the same action or just even navigate to the next page. So this was kind of created to solve that problem of being able to maintain sessions and so forth. And as you can see, my light bulb here says, think of HTTP request as a client's message saying, hey, this is what I want to do. And here's how I'm sending it. Pretty simple. Now let's talk about responses. On the server side, which as in, some of the most common servers, web servers are Apache, Nginx, and so forth. They typically will process the request that the user just sent over HTTP. A lot of times, not a lot of times, almost all the time, it will respond with some kind of status. The status basically indicating, hey, this is, I processed this. Typically, it would come in the form of the HTTP version, protocol version, and a status code. And it would either be some number like that over here, 200 right now, indicating okay. It could be a 403, not access not allowed. It could be a 500, which means server error. All of those things. We'll look at that too as well. And a lot of times, this is what a response looks like. There's a date when the response was sent. It talks about what the server version is. It tells you if it's yet to set a cookie. It tells you the content type, which essentially in this case is HTML, which is typical web traffic, content. And as you can see, the HTML body just says, welcome user, blah, blah, blah. So this is what a typical, this is the basic. At the basic, this is what a response will look like. Just to talk about a couple of things. So as we are security folks, one of the things we kind of will talk about is, okay, so what can I do with some of these things and so forth? A lot of times, whether it's the server, whether it's the cookie you're setting, responses from servers can have some useful information, not just to the client as far as your browser is concerned in terms of just doing what it can do. As with anything, you could use that wrongly, as in a malicious actor can, send depending on the type of request, and they could be trying to kind of fingerprint the server. Like in this case, you can see it tells me it's Apache 2.4.41. Now, assuming, I wanted to attack the server, I could go look for vulnerabilities and bugs that have been released and so forth for this version of Apache, hoping that maybe somebody didn't do their work on the other side by patching and so forth and all that. So that's kind of how we exploit vulnerabilities in that sense, because a lot of these can be useful information for us, depending on what it is. And I talked about this already as far as like the common elements in a response. We usually get status codes, which indicates like a success or redirection and so forth. These typically will tell us what happened to the request that we send. So as I mentioned, a 403 would be something like, hey, you're not allowed to access that resource. A 500, the server had an error, didn't respond, blah, blah, blah. And ideally, that's kind of what the status codes typically, indicate. And my light bulb here again, HTTP response is pretty much the server saying, here's what I did with your request, and here's your results. Simple as that. Let's talk about HTTP headers. I've kind of covered this a little bit in general, and I do want to just kind of get a little bit deeper into it. HTTP headers actually can be broken down into several categories. Over here, we can see their general headers, their entity headers, their request headers, their response headers, their security headers. And a lot of times what they do is they provide context about the message. So as far as like headers can provide you context about the message, they can describe the content that's being sent. They can pass credentials and session info, as I mentioned, like with cookies and tokens and authorization, and all of those things. They pretty much, kind of allow the client and server to exchange data and understand each other in terms of what data they're exchanging. If we look at HTTP headers, they're typically in, this format. You'll see a header name and a value separated by the colon. Headers appear in both request and response, as I mentioned, because this is just how they communicate. Let's now look at some of these in general. General headers, as we can see, an example is date. Date, and then there's a date actually attached to it. It says Wednesday, 16 February 2022, blah, 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 GMT. General headers such as date can be used in both request and responses. So you can see date in a request, or you can see it in a response as well too. We can talk about entity headers, which are essentially telling the servers or the clients the content type. So for example, like let's say you went to a site and you were uploading your photograph to your profile page or whatever. That content type will say something like image. If it's a file, it could say all kinds of stuff. The content type just basically describes the actual content that is being transferred to their server in that case. And then we have request headers, straightforward. We get the host, which is the example. We have user agent, as I talked about previously. Essentially, what kind of client is this user coming from? Is it a web browser? Is it a bot? Is it whatever? It would typically indicate this. A lot of these headers, just to be mindful, are like root causes or root sources of, they're very good for malicious users because, a lot of them sometimes tend to be exploitable, like user agents or cookies and so forth. I mean, there are ways you can capture cookies and reuse them even though they don't belong to you. If you're doing something like in this example where it says authorization is basic authorization is the worst kind of authorization you could have because it transfers your credentials in plain text, as we kind of talked about. User agents, sometimes like these are vulnerable to things like, SSRF, cross-site scripting, all of those kinds of things, if they're not sanitized properly. So, for security folks, a lot of these, you either, kind of set a lot of your content security settings to accept only, as we call it, allow listed things and so forth and all of that. So just be mindful of those for those of us in security as we kind of explore this. There you go. All right. Did I miss something? No, I didn't. Yeah, there you go. So HTTP client to server requests, we talked about the methods. And I kind of covered this a little bit, but we'll get into it now. When we typically look at HTTP, whether it's a request or it's a, mostly request, I'm sorry, not response. In this case, we're talking about request methods. So request methods typically have these methods. They're get, post, head, put, delete, options, patch. Each of them have their purpose. Get is typically a simple request. It retrieves data from the server. Query strings can be passed, example ID equals so forth. And those typically are also vulnerable if not sanitized and so forth. There's vulnerabilities like idle, which you can kind of like retrieve something you're not supposed to. For example, this says ID equals 10. If I wasn't supposed to access ID equals 10, which say is my ID, I can say ID equals 12, which would be another user. And if there was no kind of security checks as far as whether I'm authorized or have been authorized to access that user, then I can kind of navigate to that and so forth. Post method typically sends data. Example, when you fill in you go to a website that asks you to fill in a form or upload a file, this is the method that usually is used to send those things in the body of the request. Head typically is the same as get, but it only retrieves like headers. So head will just say, kind of give me the headers and not the body or whatever. It's typically used to check like the size or cache if needed. Put methods that just basically creates or replaces a resource. It is very dangerous if not restricted as written here. So you always want to be sure to kind of like, use those appropriately or allow those to be used by your clients appropriately. In delete method, that just, as the name implies, deletes a resource. It can lead to denial of service if not used properly. Options ask the server which methods and headers are supported. And patch partially, updates a resource. Unlike put, patch doesn't replace a resource fully. I want to talk about options just briefly. Most of the time, when you have any web server and web application typically has a list of these methods or which methods to support. That said, from the security standpoint, if you're not using any of these, you always want to make sure you're restricting that to just kind of like what you need. So, okay, you know what? We're just going to limit this to get and post. We don't allow head, we don't allow put or deletes or options. Options in particular can be very dangerous in a way because, if you allow that, it could typically be used to list like the HTTP methods that you're supporting and so forth, right? So you may not necessarily, a request could simply be by normal way that the application should work, could typically be, say, a get request. And let's say you're trying to get to, say, I'm going to use this example like ID 12, but with ID 12, no, this might not be even a good example. Let's say it's a file resource and you're trying to get to it. Ideally, if I hit get me blah, blah, blah / password file.txt, and I'm not authorized to get that, I would typically get like, say, a 403 back and so forth, right? But in most cases, if not implemented properly, I can use any of these other methods. And if the server doesn't, if your code and the server doesn't appropriately handle these, that could be a way to kind of bypass that restriction and be able to, let's say, access that passwords, that txt file and so forth. So you always want to disable the things that you're not using, just for note. And we talked about response. Since we talked about the request methods, we want to talk about responses. Responses typically, they come in, you can see there's like classes of them, and each of those classes have a meaning. And then the actual codes have a meaning as well too. So let's talk about the classes on the left side here first. There's always the 1xs, which are like informational, pretty much. And there's the 2xs, which is always kind of typically indicating some kind of success. 3xs always leans towards the redirections. 4xs, more like a bad request from the client. And 5xs typically indicates some kind of server issue. The typical ones you'll see are like 200 OK, which means like, whatever you did succeeded and the data is returned nicely. That said, a 200 OK doesn't always mean what you wanted to do is successful. I mean, what I mean is it doesn't mean your request is exactly what you wanted to be, in the sense that you could get a 200 request, but it just means your request was processed well, but it doesn't mean, say, for example, you were able to, say, access something you wanted or whatever or something. So long as the server didn't have any issue processing that request, you'll probably get a 200 OK, and it will be fine, unless we start to talk about access restrictions and all that. 302 found, usually typically indicates a redirect is in place. That's temporary. And then 400 code typically means bad request. It means your request was malformed or incomplete, or there's something wrong with it. 4.3, it's basically saying, hey, you don't have access to this resource. Either you need to authenticate first and so forth before. And 4.4, my favorite, says not found, which means whatever you requested is not found. And then we have a 500, which is like an internal server or a server error, which basically always usually points to something being wrong on the server. It could be, it could typically be servers down, whatever, overwhelmed, all of those things and so forth. Cool. I do want to talk a little bit about CRUD, which is, as much as we talk about HTTP, we do have HTTP API interaction. And the reason I kind of talked about this is because, usually when we deal with APIs, we're talking about REST APIs and streaming APIs and all those things. But there's a simple way there is CRUD, which is basically create, read, update, and delete as it is, that we can kind of like interact with APIs sometimes. So, in this state, the classes also have meanings. Create is basically talking about post request, and read is get, and update is put, and delete is delete as it is. It almost pretty much maps back to our typical way of interacting with APIs. With HTTP traffic as far as requests and responses. Anyway, perfect. Thanks for staying with me throughout. Let's gotta do a little recap of all the things we kind of covered. We talked about HTTP. HTTP is the foundation of web communication. Client send requests, servers respond. HTTPS pretty much adds a layer of security to HTTP, which naturally isn't secure. We talked a little bit about TLS exchange in terms of that. We covered request and talked about sort of what the request methods and paths and body and headers and all those other things look like. And then we kind of covered like common HTTP methods such as get, post, delete, patch, all of those things, options. And then we also kind of talked about HTTP status codes like 200 meaning okay, or 3 such as access denied and so forth. And one thing I do want to call out lastly is that headers do carry metadata, and those typically are like either host, user agent, cookie, content, and then content security policies, CSP in this case, and then things like HTTP strict transfer protocols and so forth. So this is pretty much HTTP. That's all, folks. That's my favorite line from the Looney Tunes, by the way. And so kind of like, just to recap, hopefully this was like basic. Like I said, we're trying to just give as much information. I was trying to kind of cover as much information as I can for folks that are just kind of getting into this. And for some of us who typically, like, we work in cyber and we do this all day, but we rarely go back to some of the basics to look at some of these things. So thanks for staying, and hopefully you got something out of this, and I'll catch you on the next episode.